Hello and welcome to this edition of, or next edition of the eVTOL Writers Group. Today we have a great program for you today as Embraer and Airservices Australia have just released their concept of operations. So we have members of both of those companies here to talk about that concept. And to moderate the session today, we have the editor of eVTOL Insights, Jason Pritchard. The eVTOL Insights is a website featuring the latest news, videos, podcasts about eVTOL aircraft and urban air mobility. He is a fully qualified UK-based journalist with more than 10 years of experience in media and communications. It was launched in April of 2020 and has quickly grown to become one of the leading news sources in the industry. Jason leads the editorial content for the website and hosts its popular podcast series and has been featured experts across the world who work in all areas of urban air mobility ecosystems. So, Jason, thank you very much, and the floor is yours.
Perfect. Thanks ever so much, Jim. And hello, everyone, and welcome to this latest interview from the Vertical Flight Society, as Jim has mentioned, and which I'm sure you'll all agree is going to be another really interesting discussion. Today, again, as Jim said, we're going to be hearing about the exciting concept of operations, which has been developed by both EmbraerX and Airservices Australia. The city of Melbourne is being used as a model for this CONOPS, which is also a launch city for Uber Elevate's planned aerial ride-sharing network. So I, for one, am really looking forward to hearing more about the plans going forward. Our two speakers for this session are David Rottblatt and Christian Cruikshank. David is Vice President of Business Development at EVAir Mobility and co-led the development of the UAM Concept of Operations with Airservices Australia. David's 18+ years of experience as a commercial fixed-wing and helicopter pilot bring practical experience to EVE's partnerships and engagements. Prior to joining EVE, David served as Business Development Director for EmbraerX and is the project leader of the Urban Air Traffic Management Initiative. Christian is a systems thinker, safety-focused innovator, and technology fanatic. He is an aerospace engineer with a genuine belief that technology holds the solution to many large societal problems. His experience exists at the nexus of structured, rigorous engineering and innovative, agile approaches. With a wealth of practice skills in systems engineering, software safety, assurance of autonomous systems, and a passion for advanced and complex technologies, he aims to lead technical teams to the most pragmatic and innovative solutions for difficult problems. Christian currently leads Airservices Australia's integrated airspace program focused on integration of new airspace users. So with that, David, Christian, the floor is yours. Thank you.
Thanks, Jason. Christian?
Thanks, Jason. Appreciate it. For those of you that have kids, you may understand my predicament this morning. I've got two of them with me, one yelling in the background and my wife's at work. So good evening, good afternoon, good morning, depending on where you are in the world. Really appreciate everyone jumping on this call or this presentation this morning. We're just going to run you through a bit of an overview of our CONOPS, and then we'll run into questions and answers at the end. If we could have the next slide, please, Chris. So just a quick introduction to Airservices Australia. We're Australia's civil air navigation service provider. We have a mandate of ensuring safety of all those who use our airspace. We need to ensure we're efficient with the way we deliver all of our services to those users, and need to be effective and reliable in what we deliver as well. Just for a little bit of context as to our size, relative to some other ANSPs around the world, we may not be that large, but we do cover a huge amount of the world's airspace, 11% of it. A good portion of that is sort of middle of nowhere, nobody uses it, but either way, it's our responsibility to ensure that it's managed safely. Pre-COVID times, obviously things have changed now, but pre-COVID, we managed over 4 million aircraft movements per year and 160 million passenger movements. So in terms of what we're responsible for and how it extends into this space, we need to continue to assure safety and integrity of and efficiency of airspace use, and that includes new airspace users such as drones, UAVs, and aerial taxis. And we sort of have the authority to manage the interests of airspace stakeholders, and we consider ourselves to be an honest broker between industry needs, government needs, and the regulator as well as the community. And we have an ability to shape and inform the regulatory environment by forming effective partnerships with industry players, such as we have with Embraer in this instance. Next slide, please. I think video is next. So just a really quick video on our view of future airspace management, which is predominantly focused on our integrated airspace management program, which I lead. So we can show that now.
The aviation industry is facing major challenges here in Australia and globally. COVID-19 has dramatically impacted our ability to travel. However, the long-term projections of a doubling of air traffic by 2037 may hold true and is something we need to plan for. At the same time, we are facing more complex airspace being radically transformed by technology. While COVID-19 has dramatically reduced traditional aviation traffic, it is accelerating the growth of unmanned aircraft vehicles and systems, driven by significant increases in parcel and other home deliveries and social distancing. These changes present both challenges and opportunities for our industry, which include new airspace users, new aircraft types, all with different performance capabilities, automation, digitisation and intelligence systems, as well as the ever-evolving needs of customers. That's why Airservices is making changes to the way we work. We need to meet these challenges today while planning and investing for the future to help enhance safety and improve our capacity and use of technology and data. As Australia's air navigation service provider, ANSP, Airservices has a mandate to ensure safe, efficient and equitable access for all users in Australian airspace. We are testing innovative concepts and developing new technologies to ensure the safe integration of new airspace users with conventionally piloted aircraft. We are partnering with world-leading companies and other government agencies with a current focus on the following key areas: deploying real-time drone surveillance at our airports across Australia, prototyping the development of a flight information management system known as FIMS, and designing and testing data exchange services between UTM, CTMS and ATM systems to enable drones and other low-level operators to be safely integrated with existing airspace users. We are also rethinking how airspace is designed to enhance safety and efficiency by digitising airspace information and developing new approaches for risk modelling. Airservices is Australia's airspace manager. This is a responsibility that starts at the ground and has no upper limit. We are committed to working with industry and government to advance the safety of our skies, facilitate economic growth and benefits for our community. For more information, visit airservicesaustralia.com.
Okay, so hopefully that was good overview of what we're looking at into the future here at Airservices. Obviously the collaboration we've done with Embraer cuts across a bunch of different aspects of what we just showed in that video, and also what I'll just quickly run through now. It doesn't sort of sit neatly in one of these buckets that I'll talk about. It sort of cuts across all of them, but this is how we've broken up our program at the moment. So key focus areas are aerodrome boundary management, UTM or CTMS information flow and management, and that should actually read just airspace structure in general, not low level, but covers both low level and stratospheric and anything else we need to really look at. But in terms of aerodrome boundary management, a key focus of that is our drone surveillance program. So really looking for non-cooperative drones and how to ensure we keep our existing air traffic safe in instances where there is sort of things where they shouldn't be. But it will inevitably into the future also consider how and where we integrate air taxis in and around aerodromes as well. The UTM and CTMS information flow and management, I guess, is really focused on, I guess, our development and delivery of a flight information management system for that area, but also feeds into the portion of what we've been sort of talking about in the CONOPS as well for information exchange. And then finally, on low-level airspace or airspace structure, it's all about how we design airspace to cater for new users and new operators. So next slide. I'll go over to you, David.
Thanks very much, Christian. So to briefly introduce myself again, my name is David Rottblatt. It's a pleasure to be with you all today. I'm the Vice President of Business Development for EVE Urban Air Mobility Solutions, and recently joined EVE from EmbraerX, where I was responsible for business development for that organization. So for those that aren't familiar with EVE and EmbraerX, I thought I'd just take a few moments to tell you a little bit about the company, the mission of EmbraerX, and how EVE Urban Air Mobility came about. So many of you know Embraer as an aircraft manufacturer, but you probably are more familiar with us in the commercial aircraft space by flying on our aircraft when you're flying various airlines throughout the world. But we also have an executive aviation business unit, a defense and security business unit, as well as an air traffic control technology and software subsidiary called ATEC. And ATEC is the company that creates all of that software and technology that the Brazilian air navigation service provider uses to manage their airspace, over 22 million square kilometers of airspace. And perhaps what's most unique about our work in air traffic control, and especially in Brazil, is our procedures and our technology have gone into co-creating the world's largest urban air mobility market, which is Sao Paulo, which sees upwards of 1,300 daily operations every day just for air taxis alone. And so we've learned an incredible amount by working in Brazil and building the procedures and the software that goes into making Sao Paulo such a successful urban air mobility environment. And so that is what has led us to take a lot of that expertise and know-how and bring it to the projects that EmbraerX is investing in. So that's a little bit about our background. We've been operating for over 50 years, 40 years in the United States alone, and we're very proud to be here. Next slide, please. So in October of this year, we launched EVE Urban Air Mobility Solutions. It's a company that is specifically focused on urban air mobility, and that's where we have spun out our electric vertical takeoff and land aircraft, our urban air traffic management solution, which we have been incubating for the last few years, and a services and support business. And so we have a footprint in both the United States and Brazil. And again, we have this focus on being an ecosystem-wide partner to providing those urban air mobility services that we're all excited to see come to market in a few short years. So to illustrate a little bit about how we see our technology and expertise supporting the future operating environment, the next slide will show you a little bit about how we imagine this future. So if it's not there, then I'll just say a few words about it. So what we've been working to do, and the example with Airservices Australia and our concept of operations there will illustrate that a lot more if you haven't had a chance to read it already. But it's a way for us to think about how we can build on top of the existing procedures, routes, technology, and infrastructure that already exist, but we can use those to think about how we can build the next generation of urban air mobility routes and procedures. And so from fleet operations to the air traffic management services, to interacting with both the UTM and the conventional ATM, air traffic management environment, the urban air traffic management solution is very much designed to be a complete solution that gives total situational awareness, not just for the air navigation service provider, but also for pilots, fleet operators, network operating centers, city planners and managers, and of course pilots who naturally would appreciate having that information. And so together with organizations like Airservices, EVE is now partnering and collaborating with aviation authorities all around the world so that we can help bring everything that we've learned from creating such a healthy operating environment in cities like Sao Paulo and Rio, and share that with other organizations and locales that want to position themselves to be an early adopter of the urban air mobility industry. So that's a little bit about a background of EmbraerX, Eve, and what we're looking forward to doing within Eve. To the Vertical Flight Society team, it seems that our YouTube video is buffering a little bit. Is that right?
David, it is ready to play. I thought that was a preface to the video. Would you like me to play it now?
Sure, and if for whatever the reason the audio doesn't work, as I understand that may be an issue, I can play the video on my cell phone and have the audio come through on the mic, if that's okay.
Sure. I could also play it out loud. Just know that might cause a little bit of audio refraction, but we could try that if you'd like.
Okay, whatever works. If I don't hear any audio, then perhaps I'll try it with the phone and see what happens. If you don't like it, just tell me to stop and I'll stop.
Sure. Okay. I'm going to start the video in 3, 2, 1 right now.
Great, thank you.
All right, we can go to the next slide, David. Is that? Oh,
perfect.
you've got more to go. Sorry, go for it.
So this essentially illustrates a little bit more about how our ecosystem-wide approach is designed to be applied to early adopter cities and what EVE Urban Air Mobility is looking to offer in collaboration with cities, aviation authorities, regulators, airports, etc. So we're very proud of the collaboration that we've started with Airservices Australia. In a few short weeks, similar announcements will come out about our work elsewhere, where we're working to bring urban air mobility to early adopter countries or cities that are really well positioned to take advantage of this new and exciting technology. And so if you have any questions about EVE or would like to get in touch to learn more about either Airservices or EVE, please feel free to contact Christian and myself. We'd be very happy to speak with you. So without further ado, we can now proceed to tell you about our collaboration and the concept of operation that we developed together. Christian, I believe this is yours. I think you might be muted.
Okay, now I'm unmuted. Good. Sorry, I think there was a bit of fighting going on with who was muting who. Right, so a quick introduction to the collaboration. This was essentially a research project that we've been working on with Embraer to prepare the Australian airspace and aviation industry for the growth of the UAM industry itself, so air taxis throughout Australia. What our goal was, though, however, wasn't to develop a CONOPS that was only applicable to Australia. Instead, we were working towards and have worked towards a globally applicable concept, but using Melbourne in Australia as a use case. So we found it very important to ensure that we were, I guess, tangibly applying the concepts and the approaches that we were proposing in the development of the CONOPS. Otherwise, it's very difficult to sort of, figure out what those things are that could be gotchas into the future. In terms of the Australian operational context, we've got a very strong aviation safety record, fairly mature approach to safety management. And we have a strong requirement for community engagement on matters to do with aircraft noise, for example. You'll find in Australia, we're quite sensitive to aircraft noise. So broadly speaking, if it works here, it's probably going to work in most other locations. There's also the fact that Melbourne was identified as a international air launch city for Uber. Obviously, there's been some developments in that space recently, which may impact when that occurs, but we're still basically preparing ourselves for that, and we have a fairly mature, well, not mature as yet, but a growing UAS and UTM community here as well. Next slide, please. Okay, so in terms of the research plan and objectives, we essentially wanted to propose a framework for the UAM industry to scale safely in Melbourne, and to ensure stakeholder alignment between industry, government, and where possible, community leaders. So that's involves interesting times here. Just wait, buddy. So really, we've broke things into three different. It's on there now. Go have a look. 3 different activities. So preliminary CONOPS, option and development, gathering industry, stakeholder, and government perspectives, and analysis and validation and reporting. Now, these weren't all sequential activities. They were very parallel activities, sort of starting with the basis of proposing something from the CONOPS perspective, and then gathering input and feedback on that and refining it as we went. And then in the latter stage was all about, here's a relatively mature CONOPS. Let's do some validation of that through simulation, through, getting subject matter expert input for the Melbourne airspace environment itself, and use that to refine our thinking. Next slide, thanks. So over to you, David.
Thanks, Christian. So when we started working together with Airservices Australia and we examined the existing operating environment, we quickly realized that initial urban air mobility operations, where there are already existing air taxi operations using conventional rotorcraft in cities like Melbourne, are likely not going to impose a significant threat to the current paradigm's ability to adequately serve these missions. And so therefore we expect that in the initial horizon, or those initial urban air mobility operations, those ought to be well served by the current paradigm and should fit within existing procedures. However, as more entrants to airspace continue and the segmentation of aircraft vying for access to dense low altitude urban airspace increases, we do believe that there will be some changes that will be warranted as the demand for access, as well as just the volume of aircraft, continue to grow. Judging from my own experience, just as an example, as a pilot flying in numerous countries around the world and all throughout the United States, there are many cities that are already at capacity with the availability for voice-based communication to adequately serve the general aviation traffic and airlines that are fighting for frequency space, just to be able to transmit or receive a very brief message. And so when we imagine so many more piloted passenger carrying aircraft entering operation and operating on those same frequencies, we know that a change in paradigm will be needed. And so this concept of operations started to examine exactly how that could work, beginning with the procedures. Next slide, please. And so as a result, we at least at Eve are planning on launching a piloted aircraft to begin with, but we also have an eye towards the future. And so we are building our aircraft to be autonomous ready from the outset. And so as the safety case proves itself ready for such operations, we also are preparing for the future of automation and those capabilities to make way into the cockpit. And so as the operational demand increases and these types of aircraft continue to gain access to Melbourne's airspace and others, again, it reinforced our belief that the requirements of conventional air traffic management will eventually become insufficient to provide acceptable safe levels of separation in dense low-level airspace. Hence the need for working on this CONOP together and why we developed the concepts that you read about in our document. Next slide, Christian.
Cool. So the concept of operations that we actually developed, I guess when we're considering, timing is perfect. When you're considering what our CONOPS considered, I guess encompassed, we looked at the systems and services as a whole. So that includes organizations, airspace structures, procedures, environments, technologies, people, basically everything sort of needed to support the integration of UAM vehicles within low-level airspace. So certainly not just looking at the technologies, but more broadly than that, the foundational services, the whole thing. So we focused on services being the structure, the definition of our CONOPS. So you know, basically a combination of different services is really what makes up the CONOPS and the solution. We tried to remain as agnostic as we could in terms of implementation. It does necessitate a reliance on ATM services for initial operations, but you know, we sort of expect very quickly having to move towards something more modern and advanced, and that predominantly looking at you know, UTM or UTM inspired services. Yeah, thanks, Jim. I got that. Tried to feed them breakfast before they wouldn't eat it. So you know, essentially, by looking to a relatively implementation agnostic solution, we were able to sort of look at what are the real needs and requirements more broadly. And then go towards implementation at the latter stages. Next slide, thanks. We've incorporated this concept of low-level airspace throughout the document. Now, this is not I guess, a regulatory defined term or anything like that. It's more of a conceptual definition. And really what we're trying to describe there is airspace that traditionally hasn't been used in a huge amount and is rapidly becoming filled with many different kinds of operators and platforms, such as UAVs, drones, air taxis, and existing, VFR operators as well. So when we're looking at it's airspace around aerodromes, urban, metropolitan, but also regional, where there's the need for new ways of traffic management. So there's going to be a variety of different vehicles that will include traditional aircraft as we know them today, but we need to ensure that ensure equitable access to airspace, no single UAM vehicle operator will have exclusive use. All right, thank you. Next slide.
Thanks, Christian. So one of the things that is very unique about the work that we were very proud to do with Airservices Australia is perform both fast time and real time simulations, as well as collision and risk avoidance analysis. And in doing so, and in planning for those simulations in order to demonstrate the impact that the concepts that we created were successful, we of course referenced the ICAO's key performance areas to understand what are the types of things that we need to keep in mind when we measure the impact of any new kind of procedure or operation on the existing framework and operating environment. And so these are some of the examples or example metrics rather, and key performance areas that we reference. But above all is safety. How can we make sure that we can still create a scalable operating environment and maintain the same level of safety? It's so important for us to be able to make sure that the way in which we introduce urban air mobility all around the world is done with extreme caution and extreme collaboration with all stakeholders in mind to ensure that there is the same level of safety, if not a greater level of safety than you have already been enjoying with today's form of transportation, be it in fixed wing aircraft, helicopters, or anything else that you enjoy. And so aviation today is one of the safest forms of transportation that you can have, and it is in the safest age that it's ever been in. It's never been safer to fly today, and we want to make sure that that legacy and that tradition of safety is successfully carried in to the urban air mobility operating environment. And the way that we start to do that is through CONOPS like this, and making sure that the type of simulations that we do produce results that are accurate and have these key performance areas in mind. Next slide, please. So as mentioned before, we thought about designing this concept of operation in terms of phases of growth. And so we divided the work that you'll find in this CONOPS into 3 horizons, horizons 1, 2, and 3. Horizon 1 is essentially where we are at today. There is already a degree of robust air taxi operations that exist in Melbourne, and if you've ever had a chance to visit that amazing city, it has a very unique operation in the sense that there is a floating helipad, if you will, right in the middle of the city on the river. And it is very well utilized. There can be a departure and arrival in as little as 2 minutes of each other. And so when we think about what that Horizon 1 means, just like Christian had mentioned, we also wanted to design this concept to be applicable to everyone around the world. And as there are very vibrant and robust operations in Melbourne today, there are also very vibrant and robust operations in other cities like New York, like San Francisco, Los Angeles, Mexico City, Sao Paulo, which I mentioned earlier. And so we want to learn how we can take advantage of and build on top of the existing routes, the existing procedures, the existing infrastructure that is already at our disposal today, so that we can extract the most value out of that without it having to be compromised in any way. And of course it never would. But that is what we can look forward to doing in Horizon 1. is to start these initial flights with the initial volumes of urban air mobility traffic, taking advantage of today's ATM procedures and technologies. As the price point continues to drop, as scalability happens over time, we anticipate that demand will grow as the price continues to fall. And as demand grows, we anticipate that industry would like to serve that demand with more flights and more aircraft. And that's when we'll really start to see some exciting changes taking place with respect to the procedures and the technology that will enable this industry to grow. And so between Horizon 2 and Horizon 3, we anticipate that we will start to see an adoption of new procedures, of new technologies, the growth of UTM-like services playing a larger role in how these aircraft can continue to grow and fly safely, but manage more within this network of technology and service providers that will be able to enable a much larger and robust volume of operations. And so a lot of the work that went into Horizon 1, 2, and 3 started with very accurate current data that we have today, and then we built on top of that with our directional indicators for how we think this industry will grow. Next slide. Christian.
All right, yep, thank you. So simulation results, as David mentioned, we ran a series of human-in-the-loop and fast-time simulations. The focus of the human-in-the-loop simulations is really about Horizon 1, looking at, there's, I guess, a very challenging and unique airspace design around Melbourne. Between Melbourne City and Melbourne Airport, there's another smaller aerodrome called Essendon Airport. And it essentially means that to traverse from the city to the Melbourne International Airport, you need to somehow get through Essendon airspace. It's very busy airspace, used quite heavily. And at the moment, if we to sort of use current paradigms, concepts, procedures, and air traffic control requirements, we wanted to look at, well, how far does that get us? What are the limitations, and you know, when do we run into challenges with basically human in the loop operations there? And that's a really clear indication of I guess some of the most challenging airspace. You can probably do a lot more in some areas where it's you know, where you don't have that issue of another aerodrome between the destination aerodrome. But essentially, we ran the human-in-the-loop simulations to begin validating what our thinking was and how we thought it would work. And what we found was that essentially in that airspace, the current ATM solution and approach would only be able to facilitate around 4 concurrent air taxis traversing Essendon airspace. That translates to about 10 movements per hour. And that's going to be a limitation that will be experienced very, very quickly in Melbourne as a use case. So we basically sort of showed that you know, yes, ATM can provide this service needed initially, but it's going to be very, very quickly you know, sort of maxed out essentially. And what we did with the fast time simulations is looked at compared to, you know, the current paradigm with just VFR routes and then managing VFR flights within controlled airspace. The design, the concept that we're proposing, the different services result in significantly enhanced safety, flight efficiency, capacity, and predictability benefits. Next slide, thanks. Over to David, I think.
Thanks, Christian. Well done managing everything at home and still giving a great presentation. So one thing that I think is important for all of you to think about, as we have been thinking about it, is that initial operations won't just consist of electric vertical takeoff and landing or hybrid vertical takeoff and landing vehicles, but it will also include legacy aircraft, conventional aircraft, as well as many other forms of vehicles offering intra-city or intercity flights. And so that assumption and understanding how the current operating environment works in Melbourne and between Essendon and Melbourne International Airport suggests that, at least via our human-in-the-loop simulations, that the current air traffic management in Melbourne would not be able to manage many simultaneous eVTOL operations in addition to the current workload that they have. And so that simulation environment was very much designed to demonstrate how many and in what way the human-in-the-loop experience could be able to negotiate an increase in eVTOL operations with conventional volume already in place. And as a result, we learned that Horizon 1 may be a little shorter than we had anticipated due to the controller's experience and their ability to maintain a safe workload and not to become overwhelmed with the addition of that many piloted passenger carrying aircraft. And so I think that's a very important type of study to take on. And we recommend that future urban air mobility concepts of operation seriously consider performing both fast time, real time, human-in-the-loop simulations so that every city with its particular nuances, its particular volumes, its particular procedures can understand until what point would the current paradigm work, and then when that limit is reached, how do we think about growing beyond that? And I think it's an exciting future that will very likely present these challenges sooner than we think. So as we think about designing our future airspace and looking to extract as much utility out of our airspace as possible so that we can continue to look forward to introducing more aircraft without placing any types of procedural limitations on the amount of aircraft that can fly, these types of studies we think are necessary and are part of the safety case so that we can make sure that whatever decision we take regarding how we plan on building the operating environment for urban air mobility aircraft can be a data-driven decision and a decision that you can trust. And so we're very happy to share in our CONOP, and here you have a screenshot example of how that study was conducted that supports the findings that we got from studying Horizon 1. Next slide, please. Christian, I think this is you.
Okay. Yep. So how we go about implementing it. Now, we talked about being relatively implementation agnostic, and there's a lot more work to be done in terms of how we start to implement these solutions. I guess that's future research, future work for what we currently propose. But I guess at least, you know, we have a fairly sort of strong view that UAM, UAS, traditional aircraft, they're all going to need to interact with one another in some way, or be integrated through air traffic management systems. It's essentially, there's a fine line to be worked on between how do you keep potentially solutions segregated enough to allow for moving forward with development design without being hindered by you know, existing approaches and systems, but at the same time, how do we ensure that these things ultimately become completely integrated over time? So the concept has been created to address these unique needs of UATM traffic management, but as things increase, we're expecting digitization and automated services to be the way forward. How those are going to be achieved, we have a relatively strong view, at least in air services, that UTM services are going to form a basis of some of these services, but there will likely be some bespoke services required for air taxis, and that's things like airspace and procedures design, or just unique aspects of how certain airspace authorization type services need to cater for air taxis and similar. I think that's it for us then, David. Open to Q&A unless you had something to add.
So I just want to say in conclusion, it was an honor and a privilege to work with the Air Services team. It's a very innovative ANSP that's already done a lot of work to advance the future of air traffic management and how operators together with ANSPs can build an exciting and innovative and flexible future. And so the collaboration produced what I hope will be a very well received and original contribution to the aviation industry. It's very unique in the sense that it has both fast time, real time, as well as collision risk avoidance data. So thank you to the Air Services team for their support and collaboration in creating such a great document. Over to you, Jason.
Thank you very much, David and Christian. And Christian, I have to hats off to you for delivering a brilliant presentation, and to you, David, as well. But Christian for managing all the numerous distractions. So I know I would struggle myself. So brilliant. Thank you ever so much. And we've already had some questions coming in. So thank you for those who have already put in a question as well. The first question I've got, David and Christian, is from Diran Majadi, who has said, what technology are you employing in order to automate the air traffic management for safe transportation?
So some of the things that Christian alluded to were the availability of UTM-like services that can start to play a larger role in how, I'm sorry, Christian's doing such a great job over there. How conventional air traffic control software can interact and exchange data and information with technology and service providers that on a country-by-country basis will be given certain degrees of delegation of authority or responsibility to either act in conjunction with or in concert with the ANSP, or in some cases be given certain roles that will be provided for the ANSP. And so I think that the maturation of UTM and its ultimate capabilities at some point in the future, we think will be one of those. I also want to make sure that we mention the FIMS, the Flight Information Management System technology, and the RFI that Air Services released in the fall. That is also one step closer to the automation of this industry. And that's essentially a very functional and robust communication bridge that allows different ecosystems of data like UTM and conventional air traffic management to exchange information with each other. And so I think one of the linchpins of this industry is the availability for IP and 5G networks to be able to support and sustain that seamless data exchange. And work and research is already being done to make sure that today's telcos can support this type of operating environment. I don't know necessarily how public those trials and research is country by country, but these are the first steps that we're taking to make sure that this can be a trusted future environment upon which increased automation and capabilities can be built upon. Christian, would you like to add?
I'll attempt to really quickly add to that. I think for us in Air Services, we're really looking to UTM, while it's been developed specifically for drones, UAS traffic management, it presents a new paradigm for traffic management. And so that's why we're looking at that as, extending that for digitization of services. And we're doing quite a lot of work internally at the moment to prepare for our flight information management system prototype that we'll be developing, over the next 12 months or thereabouts. And that we see as kind of the core deliverable from an ANSP into this new kind of traffic management paradigm.
Brilliant. Thanks for that, David and Christian. And next question I've got is from Nicholas Zart, who's asked, can you explain a little more about I'll start again. Can you explain a little more how your UATM system is centralized, trying to understand how it will handle the multitude of aircraft compared to Airbus's decentralized UTM approach?
Sure. So there are, I think in this very early and in some cases pre-competitive stage, different opinions and approaches for how this will work. We do advocate for a centralized system, at least within EmbraerX, and how we think our urban air traffic management system ought to interact with the regulator, the ANSP, because we believe there needs to be a central rules engine, a common source of expectations, regulations for how everyone ought to behave and interact, so that there can be as little variation in how these operations are conducted as possible in order to ensure that safe operating environment. that central rules engine, I think, and how that will work, and the degree to which different service and technology suppliers are able to make some of their own decisions may vary country by country, but we believe in having a centralized system so that everyone can pull from the same set of standards and expectations. And then again, just to reinforce that reduction in variation for how any of that could be interpreted whatsoever. Yeah, I'll leave it at that. Thanks.
Brilliant. No, thanks for that, David. Another question I've got in is from Corey Burke, who has said, are there any plans to collab with any US companies? And if not, how do we make this happen?
So speaking from the perspective of Eve Urban Air Mobility, and then if Christian wants to speak on behalf of Air Services, that would be fine. So absolutely, the question in short is absolutely. So one of the things that I did in EmbraerX is to establish the EmbraerX Partner Program, where you can go to our website and look to apply to be a partner or to collaborate with us on a few different projects that we're currently incubating. However, if you're interested in working on something in particular that is outside the scope of the projects that are listed on the EmbraerX website, please get in touch. We'd be happy to talk to you about it. I think one of the ways in which we are already planning on collaborating in order to build the urban air traffic management system, which is designed to interact with UTM, but it is one that starts with what regulators and legislators allow for today, which is voice-based communication. That is the approved form of technology for managing piloted passenger carrying flights today. And so we don't think we need to wait for the future. We think we can start now because there's already an air taxi market today. There's already some version of urban air mobility that exists today. But the technology that is allowed to manage this is within the realm of voice-based communication. And so we expect that as the safety case can be made for advancements in different forms of air traffic management technology, we'll be able to evolve the UATM solution from the services that we talked about in our video, like conformance monitoring, dynamic airspace management, from a voice-based system to evolve over time towards the data exchange system. And the way that we think we can do that is, number one, by partnering with very specific technology or service providers that can feed into our system through common APIs, which is how I understand UTM works today, for example, and very specific services like weather, for example. That is one way in which we would love to collaborate with different companies, who some of which have already been in touch with us to talk about how we can benefit from their very specific weather data, so that in environments where microclimates can significantly impact a flight from point A to point B, like in Sao Paulo, for example, pilots can be given more information in the cockpit to make that go, no-go decision, or at least increase that decision velocity. And so anything that can be done to make our product more robust, to work faster, and to integrate with other forms of technology and service providers in order to provide a more complete situational awareness perspective for anyone that wants the data is very welcome to contact us, and we'd be very happy to speak with you.
Perfect. No, thanks for that, David. Another question that's come in as well from Koei Nakamura, and he's asked, can you have any view how the contingency management of UAM should be prepared, especially in initial stage of UAM operation, because it seems the aircraft performance, especially range and endurance, may be limited?
So I'll let Christian handle that from an air traffic control contingency management perspective in today's paradigm, if I understand correctly, Jason. That's the point in time of the question. Okay.
Might be a challenge at my end, see if I come through audibility or not with the background noise. So essentially, I guess what we're looking at there is all the traditional contingency management approaches. Alternate landing sites, what can be considered safe landing location, etc. But there's also, I guess, thinking about endurance obviously is a big one, and we've all acknowledged that in the CONOPS itself, talking about you know, the reserve levels that are going to be available for electric VTOLs are obviously much smaller than traditional aircraft. So we have considered that in terms of how we designed our simulations as well. Basically looking at you know, the fact that we can't have eVTOLs doing lots of holding patterns and similar activities. They just don't have the endurance for it. So one of the key things we sort of considered as a very early, I guess, call it a UATM service or a partial service, is having the ability to have relative certainty in, you know, the availability of vertiport pads, landing pads at the other end of the operation. You don't want to be in a situation where you launch and halfway along your flight you find out it's, you know, the pad is booked out for the next 15 minutes, 20 minutes while you're, you know, arriving. So we've certainly taken that into account. There's a whole bunch of other contingency management aspects to consider as well, but broadly speaking, you know, there's ways and means of dealing with that, and looking at it in the initial instances particularly, you know, that the aircraft are still piloted, so there's the ability to intervene as necessary and clear airspace if necessary as well.
Brilliant. No, thanks for that, Christian. Much appreciated. I'd just like to ask a question from my point of view, if that's okay, David and Christian. It's great that we're using Melbourne as a model for this CONOPS, but is there then potential to add more cities in future? So I saw in the video that there's Perth, Brisbane, and Sydney that Airservices works with as well. So is there the potential then that with all the work you're doing in Melbourne, that could then go out to the other cities to help sort of bring them all together? And what can then be done to make sure that all cities are at the same page when UAM does become operational?
Yeah, certainly we do. One of the reasons that we found Melbourne quite attractive actually is because of how complex it is. So we're kind of expecting, yeah, do you want your book? We're kind of expecting that airspace in other locations is going to be easier to manage. So it was one of those situations where we figured if we look at a highly complex solution first, it gives us the ability to, you know, roll out the same concept in a much easier way in most other locations.
Perfect. Yeah, thank you very much for that, Christian. And I've got another question as well that's coming from Salim Zahir, who's asked, it's probably one for you, David, I think. What reserves are you planning on for eVTOL airplanes?
So eVTOLs will not necessarily be classified as airplanes per se. These electric vertical takeoff and landing aircraft, depending on their configuration, will be, for example, either under Part 23 or Part 27 certification standards of the FAA. Now, as it pertains to energy reserves, I think that it will be appropriate, and this is just my initial thoughts. This is ultimately a decision for the regulator. Who decides these types of things. But today, for example, we have things like 30 or 45-minute fuel reserves for either VFR or IFR missions, depending on where you're going, if it's day or if it's night, so that you can get to your destination and an alternate plus a certain amount of fudge factor time. And considering that our flights within the realm of urban air mobility are going to be significantly shorter, we anticipate that the regulator will be taking that into account when thinking about what the appropriate amount of energy reserves are going to be. I can say that it is our intent, at least in EmbraerX, to start every day with our aircraft or whoever's operating our aircraft with a full battery. And then perhaps that aircraft will fly a few missions back and forth or to wherever it's going. And then once it gets to a certain battery level, that aircraft may be either recharged or in other variants with other models that are out there, the battery could be swapped out and given a fresh battery to start right back up at 100%. And so this is something that I think industry and the regulators around the world will look forward to building together in terms of what should be that energy reserve. But what I can say with confidence is that the entire industry is very excited about the ability for battery-powered drivetrains to be capable of performing at aviation grade. It is precisely because batteries have matured to a certain point in their energy density and ability to sustain that charge that we feel confident, more than confident, that the urban air mobility industry will be very well served with battery-powered technology.
Brilliant. Thanks for that, David. Just another question for me, if that's okay. It's brilliant, the presentation you've done today, both you and Christian, to see just how you're going to sort of develop this concept of operations in Melbourne. What has the feedback been like? As you mentioned, that Australia's got such excellent aviation safety record. Has there been any feedback from government officials? And could you give a bit of an indication as to what your plans might be for 2021, for example?
Yeah, I guess in terms of government feedback, we work quite closely. We have a very strong relationship with our regulator and our Department of Infrastructure, who's our policy manager for aviation. And broadly speaking, they see it as a good first step and sort of something to build upon for Australia. We haven't received a whole lot of public feedback as yet. Obviously, the CONOPS has only been out for a couple of weeks now, I think. So still waiting on what the feedback is more generally, internationally as well as locally. But in terms of next steps, Embraer and ourselves are sort of exploring what comes next. As Air Services, we will have to continue to work towards preparing for this environment. The time frames are the things that sort of are floating right at the moment. So exactly when we need to be prepared for things is something of a topic of debate, which I assume is also similar for Embraer or Eve. Exactly when things will be ready. But we have a legal mandate in Australia to ensure that we are ready for it. It's just a matter of matching our pace with industry needs.
Perfect. No, thank you very much for that, Christian. I've got another question from Salim here as well, and he's asked, when do you expect to move into IFR ops in urban areas?
So I think that will vary based on the operator. All aircraft will likely be equipped to be able to fly in IFR. It's whether the regulator will allow it and when the operator chooses to. I think that initially everyone is preparing to start with VFR operations and then to learn by doing. I think that it is certainly my intent and Eve's intent to make sure that we're building a service and a vehicle that is capable of performing in almost any type of operating environment, the same way that you would expect an airliner to be able to take off in rain or snow, sun or shine. We plan on being there.
Brilliant. Well, certainly from my point of view, look forward to seeing how developments go sort of now and in the future, David and Christian. So thank you for that. Again, another question from myself, if that's okay. Just wanted to touch upon the infrastructure side of things as well. I know that might be another partners that you'd be working with as well, but as well as the eVTOL aircraft that you're designing and developing at Eve, David, is there any sort of conversations that you're having with sort of infrastructure? As we all know, it's that crucial bottleneck, isn't it? If we don't have the infrastructure, where's the eVTOL aircraft going to land? So is there any discussions as to how that's going to move forward in Australia and in Melbourne in particular?
Unfortunately, our Australian representative may not be available right now, but what I can say is this, is that we certainly expect that the existing airport capacity that is available today will be a resource that we will need to depend on. I think that community airports in particular, as we think about the value proposition of bringing urban air mobility closer to home, will be a resource that we will be relying on significantly in order for us to be able to fulfill expectations of being able to bring people to work or to the airport and home efficiently and quickly. Now, with that in mind, we are in the process of establishing partnerships with infrastructure players that are specializing in this space, and there will be more on that to be announced and shared soon. But I think that the way that broadly we can think about this is there is existing infrastructure that we can take advantage of in day one, just like conventional helicopters do. Then there's brownfield opportunities, so the availability or the possibility to take existing infrastructure and convert it or add to it, like hotel rooftops, parking garage rooftop, train stations, etc. And then there's greenfield opportunities. So where could we build brand new vertiports in order to add to the capacity of the urban air mobility network? And there have already been some exciting announcements in this space that are taking place around the world. I'd like to point to Singapore as an example, where there's already infrastructure and OEMs that are in place there. And that example serves to demonstrate that this is not a speculative market. This market exists, it's here. There are multiple aircraft that are going through the certification process all around the world today. And so it's just really a matter of when.
Absolutely. No, appreciate that, David. Thank you very much. Jim, we've got one more question from Salim Zahir. I'm conscious of time wise as well. Just wanted your thoughts.
Christian, you said you had, do you have a couple minutes for one more question?
I can take one more, yeah, then I'll have to call it there. Sorry, guys.
No, that's fine. Thanks for that, Christian. So yeah, it's just one final question. Again, Salim Zahir, so thank you for the question as well, is how do you plan to get micro weather patterns between buildings, for example?
So yeah, that's a good question. David, I can give you a go after me as well, but it's something we're thinking about at Air Services, and we've got some ideas on concepts. I think there's kind of ideas globally about how this may work, but there's a lot to be explored. There's services that our government weather manager, our Bureau of Meteorology, is looking to sort of enhance and deploy that will, I guess, help at a more micro scale, but around buildings in that sort of really metropolitan environment is something I think that is going to be a challenge moving forward. But I guess the concept that I think most people are looking toward is using the air vehicles themselves as sensors. So, gathering all that information on wind around the sort of urban environment as they're operating, whether that's through the urban air mobility vehicles or whether it's through drones as well, and then being able to sort of have real-time monitoring of those weather patterns, which obviously could then be used in forecasting models as well into the future.
Perfect. No, thanks for that, Christian. David, did you want to add anything else onto what Christian said?
I think ultimately that would be the endeavor of specialized companies that want to get permission from building owners or operators in order to attach or affix sensors to certain areas of the building that can then be shared with a service that company would provide that we, for example, could subscribe to. And so there's naturally a certain amount of hardware and software that's involved in creating that, but there are certainly examples for where micro weather is studied and monitored all around the world, including, for example, in Sao Paulo. The FAA, for example, in Alaska has weather cameras in very specific areas in order to help pilots, as well as the briefers that are providing weather briefings, understand how things are going in very particular areas. And so I think we can learn from that and build upon it.
Brilliant. Thanks for that, David. I know we've got a few more questions, but unfortunately we've run out of time, I think, from that as well. So David, Christian, thank you once again for all your time today as well. I think it's been a brilliant discussion. So I certainly look forward to hearing more about the developments with Air Services Australia, EmbraerX and Eve. So I'm sure everyone else will have enjoyed the conversation as well. So thank you once again.
Thank you, Jason. Thank you, Jim.
Thank you. Really appreciate it. And thanks for everyone putting up with the challenges I have at my end.
No, that's great. As you can see, it's gotten dark here on my end, and I haven't gotten up to. It's such a good conversation, and it's so much fun watching you, Christian, that I haven't gotten up to turn the light on. So thank you both. I think that was excellent coverage of the concept of operations, and thank you, Jason, for moderating our session today. We will get this recording peeled out and posted. We may do a little bit of editing. I'm not sure how much, but it's good to see that people are still being human in their workplace today. So thanks again. And then for those of you on the line, let's plan on seeing you again on December 21st as we have our next eVTOL Writers Group interview with Levitate Capital, who are going to be releasing their report on Monday the 21st. So look forward to seeing you all there. And if you don't happen to make it there, I wish everyone the best of the holidays and a prosperous new year. Thanks again, and we'll see you again soon.
Bye-bye, everyone.
Thanks, Jim. Thanks, David. Thanks, Christian. Bye, everyone.
Bye.
Have an episode, Daddy.